Half-angle identities. Today we're going to solve with half-angle identities. And with half-angle identities, I can solve for a value. Let's say I'm going to solve the sine of 30 by using the cosine of the double angle of that. For example, the cosine of 60. So let's see what that looks like. And I'm going to use it with half-angle identities. So the sine of a over 2 is equal to the positive or negative of 1 minus the cosine of the full angle. Okay? And also the cosine of the half angle is equal to the positive or negative of the square root of 1 plus the cosine of the full angle over 2. So if I'm solving for the cosine of 30, it would be the positive or negative of 1 plus the cosine of 60. I could use the cosine of 60 to solve for the cosine of 30. Now, whether it's positive or negative depends on whether the trig function is positive or negative depends on what quadrant the half angle is actually in. So, for example, we're going to solve for the cosine of 15. The cosine of 15 is in quadrant 1. The cosine is positive in quadrant 1. So this is going to be a positive angle. Okay? And the sine, looking at our next, we're going to solve these first two. You're going to solve these next two on your own. The sine of 7 pi over 8, we're solving for that. This is the half angle. It is in quadrant 2. And the sine is positive in quadrant 2, so this will also be a positive angle. Okay? All right, let's keep going. Use the half-angle identities to find the exact values of trig expressions. So the first thing we need to do is find our a. Our half angle, the sine of the half angle, a is going to be the double of that. A is going to be 30. Okay? So first thing we do, double it. Now let's use our formula. We're solving for the cosines. We're going to use this formula. So the cosine of 15 degrees is equal to the positive and negative square root of 1 plus the cosine of 30 degrees over 2. All right, solve it. What is, so we have positive or negative, well, we know it's positive, so just 1 plus, what is the cosine of 30? Well, the cosine of 30 degrees is radical 3 over 2, and we put this all over 2. Notice the whole thing is under the radical sign. All right, now I'm going to start solving this over here. I have to add this numerator, and I need to put this, I need to get common denominators. This becomes a 2, this becomes a 2. So now I'm going to keep solving. This, I have a common denominator, and this is 2 plus radical 3, and the whole numerator is now over a denominator. And when I am working with fractions like this, I like to keep this a fraction and this a fraction, so I put it over 1. Now how do I solve this? Well, I solve a division of fractions by, you know how to do this, multiplying the numerator by the reciprocal of the denominator, so 1 over 2. Okay, so I can do that. Now I'm going to bring it down here, equals the square root, again I'm still under the square root. I multiply across the numerator, and what do I have? I have 2, nothing changes in the numerator, 2 plus the square root of 3 over, multiply in the denominator, 2 times 2 is 4. And I'm done. So now I have this whole big kind of ugly thing is actually my answer. And this is the cosine of 15 degrees. And just this one time, I'm going to show you that this actually worked. So let's take our calculators. Okay, make sure I'm on the screen here. And we're going to make sure we're in degree mode. Okay, so check your calculator and make sure your mode is in degree, because I'm going to check, okay, we are in degree, and we're going to check the cosine of 15 degrees. What is that? 0.965. Now let's put this big ugly thing in our calculator. Second square root, we're going to do the numerator, parentheses, 2 plus second square root, put the 3 under there, move it over, that's the numerator, divided by 4, Now you have that ugly thing, and we're going to enter it. Look, you see that this actually worked. The cosine of 15 is, we got it. All right, check. All right, let's do one more. We have the sine of 7 pi over 8. So where do we start? Same place. First thing we do is find our a. Our a, we double that. 2 times 7 pi over 8. So we just get 14 pi over 8. Now we're going to use the sine. We're going to use the sine formula. So we say that the sine of 7 pi over 8 is equal to, now we know it's going to be positive because we've already determined it, the square root of 1 minus the cosine of the a. Now we've got a as 14 pi over 8. Can I simplify that? I sure can. These are both even, so this is 7 over 4. I can simplify that to 7 pi over 4. So cosine of 7 pi over 4 all over 2. So this is equal to, I'm going to do another color, square root. What is the cosine of 7 pi over 4? That's 45 degrees in the fourth quadrant, right? That is a 45-degree angle in the fourth quadrant. And so that's cosine sine. That is a positive radical 2 over 2. So we've got radical 2 over 2 all over 2. So what do I need to do? Well, I have this numerator. I need to get common denominators. This becomes 2 over 2. And now I'm going to keep solving. So in the numerator, I have 2 minus radical 2. Now I pull this common denominator together, all over 2. And that whole thing is all over 2, and I'm going to put it as a fraction. Now I'm going to solve my fraction by multiplying by the reciprocal. So this multiply by the reciprocal, and I am going to get the square root of 2 minus radical 2 over 4. And that is my final answer. So that's my final answer, and that answer is the sine of 7 pi over 8. Okay, 2 minus radical 2 over 4 is the sine of 7 pi over 8. All right. Now what I'd like you to do is you try 1 and 2 on your own, bring them back to class, and see how you did. Follow the half-angle identities above, and you'll be fine. Remember to keep track of all your fractions. Be careful. Don't rush it. Just be careful. All right. See you in class tomorrow.